2, 3.
What's up, team? Today we're talking rectangles, rhombuses, squares, and some properties that are involved. So let's dive right in. Rectangles. Rectangles are parallelograms with 4 right angles. If you're not exactly sure what a parallelogram is, check that video out first. So stop here, go look at that one. Because all of the properties of parallelograms fit all 3 of these figures as well. So if you're not familiar with those, check that video out first, because I'm not going to explore all that in this video. Okay, here we have an example of a rectangle. Rectangle A, B, C, D. You can see our 4 right angles. Here are some properties. The diagonals here are going to be congruent. So if you were to drop in AC and BD, those 2 lines must be congruent to one another. Additionally, opposite sides are parallel and congruent. Well, that's just one of the properties of parallelograms that we're reiterating, but it's good to see this. So BC is congruent to AD, similarly CD and BA are congruent, and they're parallel to one another, opposite sides are. Boom, boom. All right. Diagonals are congruent to one another and bisect one another. Nice. I wrote the same thing twice. That's neat. So the first and the third one, there's some reiteration, but the fact that they bisect one another, that's news. All right, so that means this line here, boom, 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 those segments must be congruent, and those segments must be congruent as well. That's true for all parallelograms. We explored that in the previous video. Next, rhombuses. Rhombuses are specific parallelograms where all 4 sides are congruent to one another. So we know that opposite sides are parallel to one another. That's just definition of a parallelogram, and this is a parallelogram. What differentiates rhombuses is that all 4 sides are congruent to one another, not just the opposite sides like with rectangles. It's all 4 sides. Okay, diagonals, perpendicular to one another. So here, when we drop in the diagonals, EH and then GE, they're going to meet at a right angle. So all 4 of these are right angles, creating right triangles. These are things that we'll be able to use moving forward. Number 2, opposite angles are congruent and the diagonals bisect them. So what that is saying here is that the entirety of angle G has the same angle measure as the entirety of angle E. Now, the diagonals also bisect it. So these are being chopped in half. So this angle and this angle, oh, things are getting real nice and messy here. These 2 are the exact same angle measure here. Similarly, on this side, they are the same measure. So E is being chopped in half by the diagonal, so is G. Really, so is F, and so is H. I'm just not marking that because it's already turning into a mess. Next, consecutive angles are supplementary. This was true with all parallelograms. Reiterating here. We have parallel lines, transversal, and then what we have is, parallel lines, transversal, EH. There we go. Same side interior angles. Angle E, angle H, same side interior, supplementary. They must add up to 180 degrees. Same is true with F and E. They must add up to 180 degrees, etc. Lastly, diagonals divide into 2 congruent triangles. So if we just look at diagonal FH, the triangle here on the bottom, FGH, and then the triangle up here, EFH, they're 2 congruent triangles. You can also split it the other way as well, and 2 congruent triangles are created. These are all properties you're going to be using to solve for missing pieces, missing angles, all that type of stuff. Now, squares. There's not as much writing over here. So a square is a parallelogram with 4 right angles and 4 congruent sides. So let's draw in our right angles, and there are 4 congruent sides. And of course, if we have right angles, congruent sides like this, their opposite sides are going to be parallel to one another. Again, that's built into the definition of a parallelogram. I'm not going to write out all the properties here because a square is really, it fits into both of these boxes. So all of the properties that are true for diagonals are also true for squares. All of the properties that are true for rhombuses listed here are also true for squares. So diagonals being congruent, if we draw them in, yeah, that makes sense. Of course they're congruent. Opposite sides parallel congruent, that's already marked. Diagonals congruent bisect one another, yeah, definitely, they bisect one another. Diagonals are perpendicular, yep, it's true for squares. Opposite angles are congruent and diagonals bisect them. Well, they're all 90, so of course they're all congruent. Diagonals bisecting them, that also is true. So all these angles created are 45 degrees apiece. Consecutive angles being supplementary, now we're getting repetitive. They're all 90. 90 plus 90 is 180. That's supplementary. And dividing into two congruent triangles, yes, that's true for squares as well. So these properties, specific to rectangles. These ones, specific for rhombuses. Squares, all of these fit squares. And again, these all fall under the umbrella of parallelograms. So all the properties we discussed in that video are true for all three of these figures as well. Okay, let me know if you have questions. Let's dive into some practice problems. You got this.